Welcome to today's class. Today we're going to be covering section 5.5 and learning about inverse trig functions and their graphs. So we've learned before about inverse functions. We know that exponential and logarithmic functions are inverses of each other. Basically, our notation for an inverse is this little -1, and essentially the inverse reverses whatever the rule of the original function was. We also learned that in order to have a function, in order to have an inverse, a function has to be 1 to 1. And we can tell that by looking at it with the horizontal line test. So we know from what we've learned about the trig functions and their graphs that they would all fail the horizontal line test. They would not be 1 to 1 because of their periodic nature. So technically, the trig functions would not have inverses. But what we're going to do is we're going to look at ways in this section to restrict the domains of our trig functions in such a way that the functions are 1 to 1 and therefore do have an inverse for restricted domains. Okay, so we're going to start out talking about the inverse sine function. So here is a graph of our sine function, and you can see that this would fail the horizontal line test. So what we're going to do is we're actually going to go in and we're going to restrict just a part of the graph to look at. So we're going to choose to look at the part from negative pi over 2 to positive pi over 2. So we're going to forget about all the rest of this. One of the reasons that we choose this part here is because we get a negative part and a positive part. And so that's going to be important as we go forward, that we have a place to look for negative answers and a place to look for positive answers. So the inverse function, if we only restrict it to negative pi over 2 to positive pi over 2, we can have an inverse because this little part would pass the horizontal line test. So the restricted domain is going to be negative pi over 2 to positive pi over 2. Okay, so what that means for us is that on our unit circle, when we're talking about inverse sine functions, we can only take our answers from the fourth quadrant and the first quadrant. I have it starting down here at the bottom and going up to the top because we're going from negative pi over 2 all the way around to positive pi over 2. And so because we're going in that order, what that means is that anything in this fourth quadrant, instead of being written as a 5 pi over 3 or a 7 pi over 6 or an 11 pi over 6, is going to need to be written as its negative angle. So this would be a negative pi over 3. This will be a negative pi over 4. And this one's going to be a negative pi over 6. So if you're asked to do inverse sine, and your answer should come from the fourth quadrant, then instead of writing it as these, you're going to need to write it as these here. The reason being these, the 5 pi over 3, 7 pi over 4, and 11 pi over 6 don't fit in this interval. But if we write it as negative pi over 3, negative pi over 4, and negative pi over 6, those do fit in that interval. Okay, so on the inverse sine function, what we've done is we restricted the basic sine function so that the domain for the sine function was negative pi over 2 to positive pi over 2. Okay, so the range we know for the sine function goes from -1 to 1. We also know that when we look at inverses, the domain and the range will switch. And so that's where we get the domain of inverse sine is from -1 to 1. So the only values we can put in here have to be between -1 and 1. And what we expect to get out is anywhere between negative pi over 2 and positive pi over 2. Okay, so this is a graph of the inverse sine function. If you recall, inverses are reflections of their original graph in the diagonal line y equals x. So if we looked at the restricted graph and the inverse, the graph that we see here, we would see that they are reflections of each other in the line y equals x. Okay, so by definition here, you've got the domain is from -1 to 1. The range would be from negative pi over 2 to positive pi over 2. And as far as notation, we're more familiar with this little -1 symbol, but you may also hear these referred to as arcsine, and you'll see it listed as like this. So just be mindful that arcsine, arccosine are just the inverse functions. We also know that if we compose two inverses together, then what happens is they cancel each other out and we end up with x. And that's true keeping in mind these domain restrictions. And we'll talk about all that as we look at lots of examples today. Basically, the way I think of this is when I see the inverse symbol, I'm thinking like that is asking the question where. So if I see like the inverse sign of 1, then that's asking the question where on the unit circle is sign 1. That's kind of the way that I interpret that. Okay, so we want to look at these examples here. So I'm going to pull up a unit circle because that's kind of what we are going to be working with. We know that for inverse sine, we can only look at the fourth quadrant and the first quadrant. So basically, we're going to forget that these two quadrants even exist. We're only looking here, okay? So what I'm going to do is I'm going to look and see this. Like I said, this -1 asked me the question where. So where on this unit circle is sine -1? So sine, remember, is the second coordinate. So if I look at all my values here, the second coordinate is -1 down here. So that location is 3 pi over 2, but instead of writing it as 3 pi over 2, I'm going to write it as -pi over 2. Okay, next, where is sine the square root of 2 over 2? So if I look at this, sine is positive in this first quadrant, so I need to be looking up here. And so sine is my second coordinate, so it's here. So my answer is going to be pi over 4. Okay, where is sine -2? Well, sine never goes below -1. So this is going to be undefined. And if you recall, we said that the domain for the inverse sine function is between -1 and 1. So if I'm trying to take the inverse sine of anything outside of that interval, I'm going to get an error message on the calculator and it's undefined. Okay, next for number 4, we want to know where is sine negative square root of 2 over 2. So sine is negative in the fourth quadrant. So I'm looking down here in this fourth quadrant. Okay, so it's negative square root of 2 over 2 for the sine function here. So I'm looking at the 7 pi over 4, but in the fourth quadrant, I don't want to write it as 7 pi over 4. I want to write it as negative pi over 4. Okay, where is sine 0? Sine is 0 here. So I'm going to give 0 as my answer. And then last, where is sine -1/2? Sine is -1/2 here in the fourth quadrant, but instead of 11 pi over 6, I'm going to write it as negative pi over 6. Looking at these cancellation properties for inverses. So basically what happens is if we compose the two functions together, the function and its inverse, then we should get x. But that's only going to be true for certain restricted domains. So here, since our inverse sine is the first function that we're starting with, we need to use its domain. So its domain is from -1 to 1. So, so we're going to get that cancellation there as long as the x is between -1 and 1. Here, because we're composing and the sine function is the one we start with, then the domain that we restricted sine to is negative pi over 2 to positive pi over 2. So if we compose those two together and our x is between these values, then we're going to get the cancellation of these and just be left with x. We need to be mindful of these different restrictions. So using our cancellation properties, here we're going to do the inverse sine of the sine of pi over 2. So with this, we need to make sure that we're between negative pi over 2 and positive pi over 2, and pi over 3 does fit in that interval. So because it fits in that interval, we're going to get that cancellation. If we look at this same interval here, 2 pi over 3 is not in this interval. It's way over here. So because of that, we don't get the cancellation. We actually have to go through and do the problem step by step. So here we need to find, first of all, with function composition, we always start on the inside. So we're going to find the sine of 2 pi over 3. So 2 pi over 3, the sine of that is the square root of 3 over 2. So I'm just going to replace all of this with square root of 3 over 2. Okay, and now I need to find the inverse sine of square root of 3 over 2. So what I'm going to do is I'm going to ask that where question. Where on the unit circle is sine square root of 3 over 2? Keep in mind that we can only look at the first and fourth quadrants for inverse sine questions. So I'm going to be looking here in the first quadrant where they're positive. It's positive square root of 3 over 2 for the sine here at pi over 3. Okay, so yes, we can do these problems. We just can't do them using the cancellation property unless this value fits within that restricted domain that we're talking about. Okay, so moving on to talking about inverse cosine. Very much the same conversation when we talk about this. We have to restrict cosine, otherwise it's not one-to-one and therefore it doesn't have an inverse. So what happens is we actually choose to restrict it to be in between 0 and pi. If you remember sine, we were between negative pi over 2 and positive pi over 2. And the reason for that is so that we'd have both a positive and a negative part to our graph. Here, if we went from negative pi over 2 to positive pi over 2, we would have just two positive parts. So that's why we look at 0 to pi. 0 to pi gives us a positive part and a negative part to our graph. And that's important when we start trying to answer our questions with that. Okay, so for inverse trig functions, basically we're going to be restricting because we said 0 to pi. Well, 0 to pi puts us in the first and the second quadrants. So for inverse cosine, we're going to be forgetting that the third and fourth quadrants exist. We're just going to be using 1 and 2. If I need a positive answer, I'm going to go to the first quadrant. If I need a negative answer, I'm going to go to the second quadrant because remember, all the cosine values in the second quadrant are negative. Okay, so with inverse cosine, we're still going to have the same domain from -1 to 1, but the range now is going to be 0 to pi. And the reason being on that, as we talked about, if we're restricting this from 0 to pi for regular cosine, we know that if we restrict that domain, then the range is still -1 to 1. And like we said before, the domain and the range will switch when we do inverse cosine or inverse of any function. We switch the domain and the range. So here, this domain becomes the range, and this range becomes the domain. Okay, so here are some cosine ones that we want to go through and do, and it's kind of the same process. If you feel comfortable and want to try these, then go ahead and try them. If not, then just watch as we go through. Here, inverse cosine is asking, again, the question where. So the little -1 indicates where. So where is cosine -1? So this time we're only going to consider first and second quadrants. So we can forget that the third and the fourth exist. So if I'm looking in the first and second quadrants, then cosine is the first coordinate, and so therefore it's going to be here at pi. If I'm looking where cosine is 1/2, cosine again is the first coordinate, and I want the positive, so that's going to be the first quadrant here. So this is going to be pi over 3. Here I'm looking where cosine is negative, so negative in the second quadrant, and I want it to be negative square root of 3 over 2, so that's going to be 5 pi over 6. Inverse cosine is square root of 2 over 2, or inverse cosine of square root of 2 over 2. So we want to know where is cosine the square root of 2 over 2. That's going to be here. So my answer is going to be pi over 4. Okay, where is cosine 1? Cosine is 1 here. So we're going to say 0. Where is cosine negative square root of 2 over 2? I need to go to the second quadrant, and it's going to be here. So that's going to be 3 pi over 4. Okay, where is cosine -1/2? Well, cosine is -1/2 here, which is 2 pi over 3. And then where is cosine 0? Cosine is 0 at pi over 2. So notice we didn't have to rewrite any of these like we do in the fourth quadrant, so it's okay to write them as they are in the second quadrant. The fourth quadrant is the only one that you have to do any kind of rewrite on. Okay, we have a cancellation property for inverse cosine as well. So if we compose cosine and inverse cosine, they're going to equal x as long as we keep track of our domain. So if we have inverse cosine on the inside here, then we need to follow its domain, which is -1 to 1. If we have cosine on the inside, then we need to follow its restricted domain, which is 0 to pi. Okay, so this is the graph of inverse cosine. We're not going to do much with the graphs of the inverse trig functions, just the basic trig functions themselves. You should know those graphs, but you do not have to know the inverse trig function graphs. Okay, so looking at this one, we said that the domain for cosine is restricted to between 0 and pi. So as long as this value is between 0 and pi, then we get the cancellation property to hold. So 2 pi over 3 is between 0 and pi, and you can see that on the unit circle. 2 pi over 3 is here, so it is between 0 and pi. So that means these are going to cancel, and that's just going to leave me with 2 pi over 3. Okay, now on this one, again, looking at this domain, 5 pi over 3 is all the way down here in the fourth quadrant. So it's definitely not between 0 and pi, which would be these first two quadrants here. So because of that, I can't use the cancellation property. I just have to work through it. So as any composition problem goes, I'm going to start here in the middle. So I want to find the cosine of 5 pi over 3. So I'll go down here to 5 pi over 3, and the cosine value is 1/2. So all of this is going to get replaced by 1/2. Okay, so now I need to ask myself, where is cosine positive 1/2? So my positive cosine values come from the first quadrant, and cosine is the first coordinate here, and so that means my answer is pi over 3. Okay, moving on to talking about inverse tangent functions. So with the tangent function, if you remember from section 5.4, the one we just finished, tangent goes from -pi/2 to +pi/2. It has vertical asymptotes at each of these values here, and then it looks something like this, and then it goes and it repeats, and we have multiple parts to our graph, and same thing over here. So what we do with inverse trig is, the inverse trig function, in order to have an inverse trig function, we've got to restrict our domain so that it'll pass the horizontal line test. Well, it makes sense just to look at one of these graphs here, and the one that we choose is actually going to be this one centered at the origin. So this is the graph that we're going to look at for our trig function so that it passes the horizontal line test. So the domain for this one, when we restrict it, is going to be from -pi/2 to +pi/2, and the range on that restricted one is -infinity to +infinity. So when we look at the cancellation properties for this one, we've got to keep in mind those domain restrictions. So for the inverse tangent, I'm going to go back here. For the regular tangent function, we had a domain of -pi/2 to +pi/2, but that means that that's going to be the range of my inverse function. And then the range of my regular function is going to be the domain of my inverse function. So I need to keep all of that straight as I'm going through this. So looking at this one, if inverse tangent is in the middle here, then my domain is all real numbers. If tangent is in the middle, then I'm restricted to being between -pi/2 and +pi/2. And these are just graphs of the inverses. Again, we're only looking at this red one, not all these other graphs. Okay, so for inverse trig, for inverse tangent, because we are restricting ourselves to be in between -pi/2 and positive pi over 2, that's going to keep us in the fourth quadrant and the first quadrant. So what happens is inverse tangent and inverse sine are going to come from the first and fourth quadrants. Inverse cosine is going to come from the first and second quadrants. So it's really important to keep that straight. And for both inverse tangent and inverse sine, you're going to need to rewrite the values that appear in the fourth quadrant as the negatives of those measures. Okay, so this kind of summarizes it. For the inverse tangent, which is the last one we were talking about, the domain is all real numbers, but the range is only from negative pi over 2 to positive pi over 2. And we've already talked about inverse sine and inverse cosine. Okay, so for inverse sine, if you're needing a positive value, you'll go to the first quadrant. A negative value, you'll go to the fourth quadrant. Inverse cosine, it will be first and second quadrants, and inverse tangent will be first and fourth quadrants. And notice in those fourth quadrants, we need to write it as the negative of the reference angle. So it's a little bit helpful on these when we start looking at inverse tangent that you kind of memorize some of these values. If you have a reference angle that's a pi over 3, then the tangent of that is the square root of 3, because if you remember, pi over 3 is going to be 1/2 square root of 3 over 2 for its terminal point. So what happens is when I do tangent, tangent is y over x. So I'm going to have the square root of 3 over 2 divided by 1/2, which is the square root of 3 over 2 times 2 over 1. And that's going to give me the square root of 3. So when your angle is pi over 3, tangent's always going to end up being the square root of 3. So always remember that the 3 and the 3 go together here. Pi over 6, if I went through the same process for pi over 6, and I'm not going to repeat all of this, the coordinates here, what I would end up with is square root of 3 over 3. And one thing I remember, this is just a kind of a helpful little hint, 3 plus 3 equals 6. So for the pi over 6, the tangent is the square root of 3 over 3. For pi over 4, you have the square root of 2 over 2 and the square root of 2 over 2. So if I divide something by itself, I'm always going to get 1 for the tangent on that. And so anytime you have 1 or negative 1, it's going to be a pi over 4 type angle. If you have the plus or minus of this value, it'll be a pi over 6 type angle. And if you have the square root of 3, it's going to be a pi over 3 type angle. Okay, so looking at this one here, and going back to what I just said, here I'm looking for where tangent is -1. Well, on our unit circle, all we see is sine and cosine. We don't see the tangent. That's why what I was just talking about is important, because in order to have a tangent of -1, our x and y coordinates have to be the same values. Okay, so we're talking about a pi over 4 type angle. If we need it to be negative, that tells me it's in the fourth quadrant. So it's going to be here at this 7 pi over 4, but remember, we don't write it as 7 pi over 4, we write it as negative pi over 4. Okay, here we want to know where is tangent the square root of 3. If you remember, I said the pi over 3s are the type angles that have a tangent that's the square root of 3. I mean, you can go through and try that if you want to, but we've kind of already looked at that. So, and it's positive, so that tells me my answer is just going to be pi over 3. Here, the square root of 3 over 3, we said that those are the ones that 3 plus 3 is 6. And so we want it to be positive, so that's here in the first quadrant. So pi over 6 is going to be my answer. Okay, here we need tangent to be 0. So that's a little bit trickier. That's definitely going to be at one of these values here. We just have to decide which one. Okay, so if we're going to do tangent is y over x. So if I divide this y by this x, that's undefined. 1 divided by 0 is undefined. 0 divided by 1 is going to be 0. So that's my value there. the tangent of 0 is 0. Here I need to find where tangent is negative square root of 3. So again, the type angles that have a tangent that's the square root of 3 is pi over 3. And if I need it to be negative, then it's got to come from this fourth quadrant. So it's going to be a negative pi over 3. This one, where is tangent negative square root of 3 over 3? So the pi over 6 angles have a tangent that's the square root of 3 over 3. If I need it to be negative, then it's got to come from the fourth quadrant, so it's going to be negative. Okay, the pi over 4s are the ones that have a tangent that's either 1 or negative 1. So if I need it to be a positive 1, then that means both their signs need to be the same. So that's going to come from that first quadrant and be pi over. So on this one, we have a value that is not on the unit circle, but it is within the domain of inverse tangent. If you recall, the domain of inverse tangent was all real numbers. So this is one that you would just have to do on your calculator. And for now, we want to be sure that we're set in radians. So if we do the inverse tangent of 20, you get 1.521 as your answer. Okay, so you do have the inverse functions on your calculator. They're just the second function to the regular 3 trig functions, and that'll take you to the inverse trig functions. Okay, here are some for you to try using the cancellation properties. So I'm going to ask that you pause the video at this point and try these problems, and then check your answers. Okay, on the first one here, they're numbered 22 because I took them from a textbook. Here, this from our textbook. So this one, if we're looking at the inverse sine of the sine of pi over 4, this fits within that domain of negative pi over 2 to positive pi over 2, and therefore we can use the cancellation property on that one. This one is within the domain of 0 to pi for cosine, so we can use the cancellation property there. This one is outside of that, so we need to find what sine of 3 pi over 4 is. So if you go to 3 pi over 4 and look at the y coordinate, that's the square root of 2 over 2. And then we need to know what inverse sine of square root of 2 over 2 is, and that's going to be pi over 4. Here, 3 pi over 4 fits within this domain for cosine, and therefore those will cancel, and we'll get the 3 pi over 4. Same rationale for 5 pi over 6. If I look at inverse sine of the sine of 5 pi over 6, 5 pi over 6 does not fit within this domain here, and therefore we have to actually go through and work it out. So the sine of 5 pi over 6, we're going to go to the second quadrant and get the y coordinate for 5 pi over 6, which is 1/2. And then we'll do the inverse sine of 1/2. So the place where sine is 1/2 is going to be pi over 6 for our answer. On this next one, 7 pi over 6 is not within the domain of 0 to pi, which is necessary for cosine. So we've got to go to the unit circle and locate 7 pi over 6. 7 pi over 6 is in the third quadrant, so the cosine would be negative square root of 3 over 2. So now I need to find out where is cosine negative square root of 3 over 2. I can only look in the first and second quadrants, and the first quadrant's for positive answers, the second quadrant's for the negative ones. So I need to look in the second quadrant, and that's going to give me my 5 pi over 6 as my answer. The next one here, 7 pi over 6, is again not within my prescribed domain of negative pi over 2 to positive pi over 2. So I need to answer this part first. So the sine of 7 pi over 6 is going to be in the third quadrant. So that's going to be negative 1/2. So then I need to find where is sine negative 1/2. And the answer to that is in the fourth quadrant. It's going to be at 11 pi over 6, but we don't write it as 11 pi over 6. We write it as negative pi over 6. And then on this one, for tangent, we need to be between For our domain for tangent, we need to be between negative pi over 2 and positive pi over 2. So pi over 4 is in that interval, so we get that cancellation, and we're just left with the pi over 4. Okay, here's a few more for you to try. Okay, this one is for tangent. This is between negative pi over 2 and positive pi over 2. So we do get the cancellation property to hold there. This one, 2 pi over 3 is not between negative pi over 2 and positive pi over 2. So I need to answer this. Tangent of 2 pi over 3, that's in the second quadrant. So my pi over 3's always have a tangent that's the square root of 3. And in the second quadrant, that's going to be negative. So then I've got to find out where is tangent negative square root of 3. Remember, for tangent, I'm restricted to the first and the fourth quadrants. So if I'm looking for a negative, it's going to be in the fourth quadrant. So that would be negative pi over 3. So it would be the location of 5 pi over 3, but we would write it as negative pi over 3. Okay, on this next one, this is outside the domain, so we're going to need to work through that. 11 pi over 4, you're going to actually need to divide into that. So that's the same thing as 2 pi plus another 3 pi over 4. So 2 pi, I go around the unit circle one time, and 3 pi over 4 takes me to the second quadrant. So in the second quadrant, the pi over 4 is, the sign of a pi over 4 is going to be positive square root of 2 over 2. So when I do inverse sine of square root of 2 over 2, I need to know where is sine square root of 2 over 2. That's going to be pi over 4. Okay, on this one, we're looking at inverse sine of 1/2. So I want to go and find where sine is 1/2, and that's going to be pi over 6. And then I want to give the tangent of pi over 6, and that's going to be the square root of 3. This should be over 3. Okay, here I need to find where is sine 0. Sine is 0 at 0, and the cosine of 0 is 1. Here I need to find where is sine square root of 3 over 2. So that's going to be at pi over 3. And the cosine of pi over 3 is 1/2. For this one, I need to find where is sine the square root of 3 over 2, and we just said that was pi over 3, kind of a repeat of this problem. So the tangent of pi over 3 is going to be the square root of 3. Again, if you don't remember these for tangent, then you can work them out. That's fine as well. Here, inverse sine of square root of 2 over 2. So where is sine square root of 2 over 2? That's going to be pi over 4. Tangent of pi over 4 is 1. And then here we've got where is tangent negative 1. So that's going to be in the fourth quadrant that it's negative. So that would be the 7 pi over 4, which we'll write as negative pi over 4. And the sine of negative pi over 4 is going to be negative square root of 2 over 2. Okay, and here's a few more if you'd like to practice more. Okay, the first one here, we're going to find where is tangent negative square root of 3. So that's going to be in the fourth quadrant, so it'll be negative pi over 3. The sine of negative pi over 3 is negative square root of 3 over 2. Okay, here I'm going to just kind of recap for inverse sine. Okay, for inverse sine, your domain is going to be negative 1 to 1. For inverse cosine, that domain is negative 1 to 1. And then for inverse tangent, that domain is all real numbers. So as long as, on all of these, as long as we stay within those domains here for the inverse trig functions, because that's what's in the middle of each of these, then we're going to get to use our cancellation property. So on this one, we're looking at the inverse sine of 1/4. Well, 1/4 is here, is in between here. So that is going to allow these to cancel and we equal 1/4. Here, 2/3 is between -1 and 1, so we get that cancellation. Here, inverse tangent is where we start, and its domain is all real numbers, so we get that cancellation. Inverse sine on this one, you've got 5 is not within the domain for inverse sine, and that's why this one would be undefined. Here, 3/5, 3/5 is within the domain, so we can use the cancellation property. For tangent, 3/2 is within this domain, and so this is going to be, we can use the cancellation property. This one for cosine, -1/5 is within that domain, so we can use that cancellation property. And then here, the -3/4 is within this domain, and we can use the cancellation property. So just looking at these, I just wanted to kind of emphasize that on these problems here, a lot of them, or at least the first part of the problems that we've worked with, you had the original function here on the inside, and therefore that's why we were using these domains. Once we switch to having the inverse trig functions on the inside, then that's when we're going to switch to these domains here. So it depends on which function you have on the inside as to which domain you need to be using in order to apply the cancellation properties. Okay, that concludes our lesson on inverse trig functions. This is a very important section because as we go on and start solving trig equations, you're going to need to understand and be able to use these inverse trig functions. So hopefully you're going to do well with that. If you have any questions, please let me know, and I hope you have a good day.